Welcome to Huawei eLearning Services. My name is Klaus Schweiger and today I will give you an overview of Huawei SDN All-Service Solution. After completion of this course, you will be able to describe the SDN All-Service Solution from Huawei. Firstly, let's talk about Huawei's carrier IP SDN architecture. Fundamentally, Huawei's IP SDN architecture provides a solution to carriers to enable them to transform existing network and data center infrastructure to simplify and automate its operation management processes, and so to empower the creation of new business value propositions. One of the main building blocks of the SDN architecture is the separation of user plane and control plane. So the SDN controller plays an essential role in this architecture. Let's have a closer look at the SDN controller architecture from Huawei. uTraffic is Huawei's network traffic analysis system providing real-time statistical information about network and services via southbound interface (SBI). This information, network and service SLA information, will be forwarded to NetMatrix. NetMatrix is the orchestration system which provides end-to-end intercontroller orchestration. The OSS/BSS OpenStack will specify service policies. The service policy-based network constraint adjustments now will be forwarded to the network controller. SNC, which is Huawei's smart network controller, acts as the center of the SDN network. It is handling control policy management and optimization to enable carriers to reduce their operating expenses and roll out new features and services more quickly. It is supporting a couple of new features we will talk about during this course, like RR+, PCE+, IP+ optical, and so on. The network controller will send back real-time forwarding policy adjustment via the network resource and configuration management to the network elements. Finally, the architecture also requires a virtualization management system to manage the virtual network. The Huawei carrier IP SDN solution is suitable for fixed network access via DSL, FTTH, OLT, as well as for mobile access networks, CSG, AGG, and RSG. These access networks will be connected to an IP-based core network. This interconnection in the core typically will be based on optical transmission technology, and this finally provides access to the data center DC. For the SDN architecture, we are using IP-RAN virtual cluster. As for the mobile backhaul, and GI LAN service chain as for interconnection between mobile network and internet. As for the cloud edge solution, we use VAR, which is Virtual Access Router, to provide virtualization services to enterprises. The IP Core DCI, which is Data Center Interconnection, is based on RR+, on PCE+, on Smart Traffic Engineering, and IP and Optical. For the data center, the Huawei solution will be based on SDN, on VXLAN, which is Virtual Extensible LAN, and Service Chain. So first we have a look at the data center in the Huawei SDN solution. Huawei's SDN solution helps to simplify the process to transform data center solutions into IaaS solutions, which is Infrastructure as a Service. So a company does not necessarily need to own their servers and storage devices, but may rent the service on demand. To provide that and optimize that solution, Huawei's solution is based on three key features. Network virtualization, which means SDN plus VXLAN seamlessly bring network virtualization to existing networks. Second, network level open API, which means an app-oriented open API helps the service providers to focus more on resource utilization than on the specifications of their physical devices. And third, VXLAN-based service chain, which allows to provide per tenant, per app, NFV, Network Function Virtualization subscription, and to enable arbitrary service execution. In the following slides, we will go into more details about these three mentioned key features. Key feature 1, network virtualization provided by SDN plus VXLAN. Some words about VXLAN, Virtual Extensible LAN. It is standardized by the IETF and it describes a framework for overlaying virtualized layer 2 networks over layer 3 networks. So it is a network virtualization technology that attempts to improve the scalability problems, especially associated with large cloud computing deployments. It uses a VLAN-like encapsulation technique to encapsulate Ethernet layer 2 frames within UDP packets, which is layer 4. And we use a default UDP port of 4789 for that. It provides up to 16 million logical networks by 24 bits, so far enough layer 2 networks to allow adjacency across IP networks. The advantages of using SDN plus VXLAN are also shown with this picture. Please just look at the enhanced numbers. Advantage number 1. The VXLAN provides a scalable non-blocking network if providing 16 max of VLAN IDs. This is more than 4,000 times of traditional VLAN based on IEEE 802.1q. Centralized SDN control, this is advantage 2, of VXLAN to provide simplified deployment and best support of VM migration. Advantage 3, VXLAN can be deployed at the edge of existing networks. This means there is no need to do massive upgrading. And advantage number 4, dedicated gateways and quality of service ability for VXLAN. This will strengthen multi-tenant operations, especially for wholesale and retail scenarios. Let's come to key feature number 2. Network-level open API for app-oriented integration. The tenant may only focus on applications. It will subscribe to virtual data center and the data center interconnection. The carrier will be responsible to manage the requested resources. The deployment of the service is automated by controller built-in intelligence and open APIs. There is a central data center interconnection controller, DCI controller, shown here, and a DC controller for each IDC. The DC controllers will automatically allocate network resources in the DC fabric. The communication in between them will be based on open APIs. So from the DCI perspective, the northbound interface NBI fully supports RESTful interface, which best coordinates computing resources. The southbound interface SBI can be based on OpenFlow, on NetConf or CLI interfaces, which provide extensive serviceability and compatibility to traditional network devices. Key feature 3, VXLAN-based service chain. This feature allows to provide a per tenant or per app-based subscription of a virtual application. In our example, the tenant uses from a pool of virtual appliances, firewall function, service load balancing function, and deep packet inspection function. Our centralized SDN controller now is providing the VXLAN management function. This management function is responsible for the traffic control for our tenant. So it will set up the connection from tenant ingress to tenant egress via the requested application devices, for instance, firewall or DPI. The protocol used between control plane and user plane can be OpenFlow protocol. As we have seen, this VXLAN-based service chain provides a couple of advantages. It can provide a uniform VAS pool per tenant or per app and an on-demand resource allocation and utilization for differential virtual appliances. It can be seamlessly integrated into existing networks, and it can provide a centralized and therefore an easy deployment and extensive scalability for carriers. So to use the VXLAN-based service chain can create new benefit for the carriers. Now you know the basic architecture of Huawei's SDN all-service solution. Thank you for watching.